Okay, this problem was posted several years ago. Excuse me. But I had a student who was interested in basically how to find the length of BD if there were different ways to do it. So uh, here's rhombus ABCD, which means all its sides are congruent or equal in measure. Here's some properties of rhombi. This is the one we're going to use specifically, and that is that the diagonals of a rhombus are perpendicular to each other. They also bisect each other. I don't think that's in this list yet. They bisect the opposite angles. So this is 36 degrees also. Consecutive angles of a rhombus are supplementary, a parallelogram are supplementary. So we could find this angle, or we could look at this right triangle and subtract from 90 to get this acute angle. So there's quite a few ways to answer part A. But probably the most straightforward is to say, the cosine of 36 is adjacent over hypotenuse, and then solve for S. So S equals 40 divided by the cosine of 36, which is about 49.4. You could also do it with the secant ratio. The secant of 36 equals S over 40. So S equals 40 times the secant of 36. So there it is, to a few more decimal places. To get the perimeter of the rhombus, you just have to multiply that number by 4. And finally, to get the length of diagonal BD, there's 3 or 4 different ways to do it. This equation illustrates the law of cosines. Because we're trying to find BD, we know its opposite angle is 72, and we know the length of the two sides that include that angle. So there's the law of cosines. I go to board 2. I use the distance function on Desmos to calculate the distance between B and D. There it is, 58.12. Here's the Pythagorean theorem. I'm sorry, there's the law of cosines that I had on the previous board where S was at 49.44. Here's the Pythagorean theorem. I'll go back here. Where did that come from? Well, if we call this little distance right here A, then A squared plus 40 squared equals S squared. So A squared equals S squared minus 40 squared. Take the square root of that and you've got A, but then you've got to double it to get BD. And that's what this is right here. Same result. The other way to do it is just use right triangle trigonometry. So in this triangle right here, I'll call it triangle Roman numeral 1. The tangent of 36 equals opposite over adjacent, A over 40. So A equals 40 times the tangent of 36, but then you got to double it to get this length down here. And you can see that these all give the same answer. According to the problem posted, you're supposed to round to the nearest integers, so that answer is 58. There you go. Hope that helped. If you have any questions, post a comment.